Okay, in this video, we will solve two problems that involve Gay-Lussac's law, where it's pressure initial divided by temperature initial is equal to pressure final over temperature final, where both of our temperature must be in Kelvin. And so let's do our two problems. Question 1. Determine the new pressure when a constant volume of a gas at 3 atmosphere is heated from 50 degrees Celsius to 75 degrees Celsius. So our initial condition is 3 atm and 50 degrees Celsius, and our final condition is 75 degrees Celsius, where we do not know our final pressure. That's what we're trying to solve for. We're determining new pressure. And so let's use Gay-Lussac's law formula in order to solve final pressure. So initial pressure we have is 3 atm. This is going to be divided by our initial temperature in Kelvin. Must be in Kelvin. So we're given in Celsius. And so we can say 50 degrees Celsius plus, in order to convert from Celsius to Kelvin, you always add 273.15. And so now this value right here is in Kelvin. And so this is equal to, we do not know the final pressure, so we can call it, PF. We're trying to solve for final pressure divided by the final temperature is 75. Likewise, we need to convert to Kelvin. 75 plus 273.15 Kelvin. And so now we can cross multiply and ultimately solve for PF. So PF is equal to this piece right here. So this piece is 3 over our 50 plus 273.15. We're cross multiplying times this bottom part right here. 75 plus 273.15. And let's check our units. So this is atm, this is Kelvin, this is going to be atm, this is going to be Kelvin. So we're solving for atm. And we could say that this piece right here is atm. This piece right here is Kelvin. And the denominator here is Kelvin. So Kelvin cancels. And we're left off with atm. So that is correct. So you multiply it out, and you would get 3.23 atms. This right here is the final pressure. Now we'll do the second problem. So gas in a closed container is in a pressurized form. We have 5 atm at 25 degrees Celsius to 10 atm. We want to determine the final temperature. So this problem is a little bit different. So here we were solving for final pressure. And now in this problem, we're solving for final temperature. And so let's do it. And so let's get some more room and solve this problem. So let's go back to the equation. It's going to be P initial divided by T initial is equal to P final over T final, where both our temperature has to be in Kelvin. We know that the initial condition is 5 atm at 25 degrees Celsius. So pressure is 5 atmospheres divided by temperature. We know it's going to be in Kelvin, so 25 plus 273.15 Kelvin, K, is equal to, we know the final pressure as 10 atm, but we do not know the final temperature, so TF. So now this is an important note, and we also want to solve this in Celsius. So right now, this is atm, Kelvin, atm, Kelvin. So this right here is actually in Kelvin. So when we initially solve for TF, it's going to be in Kelvin. But then we need to go back to Celsius, because that's what the question is asking us. So cross multiplying here might be a little bit more challenging. So you're going to bring the TF over here. So you would get 5 over 25 plus 273.15, close parentheses, times TF is equal to 10. From here, we will divide this piece over to the 10. So TF is equal to 10 divided by, we have 5 over 25 plus 273.15, close parentheses. And so if you were to divide everything up, you would get 596.3 Kelvin. And now we want to convert from Kelvin back to Celsius, And so you would have to subtract 273.15. So if you subtract 273.15, this right here will be 323.15 degrees Celsius. And that's all we need to do for this problem.